6.3 Chatelier principle. What is the Chatelier principle? It's a system equilibrium is disturbed. Disturbed means that disturbance by change in temperature, pressure, or component concentration. The system will shift its equilibrium position. Shift equilibrium position meaning that reduce the disturbance. So as to counteract the effect of disturbance, or another meaning is reduce the change or reduce the disturbance. So now in Chatelier principle, you can see disturbance and then equilibrium position. Try to reduce the disturbance by shift to the left and or shift to the right side. Okay, so let's say example, you feel hungry, right? So you must eat. You feel stressed, right? You must release stress so that you balance now. So this is the Chatelier principle. So the disturbance we'll discuss for the video is concentration, pressure, and the temperature. So today we'll discuss the effect of concentration. So to discuss the Chatelier principle, so now I will discuss with the three items. First one is a disturbance. What kind of disturbance? Second is how to reduce the disturbance. And the last one is equilibrium position, will shift to the left or right or how. Okay, first case is let's say concentration added to the system, meaning that the concentration increase. So how to reduce the disturbance? So we'll decrease the concentration. So how to decrease the concentration? Equilibrium position will shift to consume the substance. Consume means the substance will react. So after react, right, the concentration A will decrease. So now second case, if a concentration remove, let's say you produce one product, so you remove it, so you have found that concentration decrease. So how you reduce the disturbance? You must increase the concentration. How you increase the concentration in the system? You must shift to the side which is can produce more substance. So once you know the right direction need to consume or need to produce, then you can predict the system will shift to the left or shift to the right side. How about the concentration? Is it affect the equilibrium constant K? The answer is no change, because according to law of a mass action, the equilibrium equilibrium constant is a constant when the temperature constant, meaning that concentration is not affected to the equilibrium constant. Okay, now I will discuss three cases. Okay, case number one. So you can look at here. This is an equilibrium condition, PCl3, Cl2, and PCl5 at equilibrium condition. Okay, now let's say I add the Cl2. That means I increase the concentration of Cl2. So what you can see is the concentration of Cl2 will increase. Right. So this is called disturbance. So how we reduce the disturbance? We must decrease the concentration of Cl2. So how we decrease the concentration Cl2? We must consume the concentration Cl2. So consume meaning that the PCl3 will react with Cl2, so they produce a PCl5. So they shift to the right, they produce PCl5. So once they produce PCl5, meaning that concentration for the PCl3 will decrease, and then concentration Cl2 will decrease, and concentration PCl5 will increase. So meaning that, so now at the end, we already reduce the concentration of the Cl2. At the same time, it will increase the product and decrease the concentration of reactant. Okay, now this is a case 2. Now I increase the concentration PCl5. So this is at the equilibrium condition. Now I increase the concentration PCl5. So this concentration PCl5. So this one is called disturbance, gangguan. So you must reduce the concentration PCl5 by consume it. So how we consume the PCl5? So they must shift to the left side. They must shift to the left side, meaning that PCl5 will produce the PCl3 and Cl2. So after PCl5 produce PCl3 and Cl2, concentration for PCl5 will decrease. Okay, look at here. So you can see the concentration for PCl5 will decrease, then the concentration for the PCl3 and Cl2 will increase. So this one we call disturbance, and we try to reduce the disturbance, so achieve equilibrium. Alright, okay, now case 3. So case 3, right, this is a equilibrium condition. Now the disturbance is remove the PCl5. Remove PCl5 meaning that concentration of PCl5 will decrease. Concentration PCl5 will decrease. So you must increase the PCl5 again. So how you increase the PCl5? You must produce PCl5. So in this system, how you produce PCl5? So they must shift to the right side to produce PCl5. So that means PCl3 will react with Cl2 will produce the PCl5. So at the end, you will find that concentration of PCl5 will increase, and the PCl3 and Cl2 will decrease. So system will shift to the right. So that means the disturbance now is a concentration PCl5 decrease. So how to so the equilibrium must increase concentration PCl5. How? We must shift to the produce it, the side produce it. So that is a right side. Okay, this is one of experiment 5 chemical equilibrium part 8 effect of concentration. Now this is a Fe3 plus yellowish, and this one is a tricyanosyl 3 complex in the bird red color. These 3 item species combined together, they will achieve equilibrium. So equilibrium color is a bird red color. So this is your in equilibrium condition. Okay, now we study 2 cases. Case number 1 is a disturbance. I increase the concentration Fe3 plus, meaning that you must reduce the concentration Fe3 plus. So how you reduce the concentration Fe3 plus is you must consume it. You must consume, you must react, or you must use so that concentration Fe3 plus can reduce. Okay, now, so how we reduce the concentration Fe3 plus? The system must shift to the right side. Why? Because Fe3 plus can react with the HCl minus, produce a more tricyanosyl 3 complex. So at the end, concentration Fe3 plus will decrease. So your observation is once we produce more tricyanosyl complex ion, that means the colors is a bird red. That means you can see intensity of bird red color increase. Now, how about case disturbance? Increase the concentration for HCl minus. So once you increase the concentration HCl minus, so you must reduce the disturbance by decrease the concentration of HCl minus. So how you decrease it? So you must consume also. You must consume, react, or use. Okay, how you decrease the concentration HCl minus? So same method, you must react and shift to the right. So at the end, concentration HCl minus will decrease. So once you produce a more tricyanosyl complex 3 ion, so that's why intensity of the color, you can see intensity of color for bird red color increase. So this is the effect of concentration. Okay, how about the third case? The third case is we decrease the concentration Fe3 plus. So once you decrease the concentration Fe3 plus, meaning that you must increase the concentration of Fe3 plus. How? You must produce it. So according to equation, how we produce the more Fe3 plus? So the equilibrium position will shift to the left. So when they shift to the left, you'll produce more Fe3 plus and HCl minus. So once you produce more Fe3 plus, the color now is a change from the bird red color from the yellowish brown. So where is a Fe3 plus is a yellowish brown. So this observation from the experiment. Alright, okay, now I teach you how to do the analysis. This one is called analysis. from here, disturbance, how to reduce disturbance until equilibrium position shift is the analysis. And then once you know analysis, you're able to do your own explanation. Okay, now, so first case is a when. When is a disturbance, reactant is added. Let's say I add the SO3. So meaning that concentration SO3 will increase. So how to reduce the disturbance? So you must decrease the concentration of SO3. So how you decrease the concentration SO3? You must consume, or you must let the SO3 to react. Okay, so how to solve the problem? They must shift to the, according to equation, to reduce the concentration SO3, you must shift to the right side. Because when they shift to the right side, right, SO3 will produce more SO2 and O2. So at the end, concentration SO3 will decrease. So it means from this equation, they shift to the right side. So how you do the explanation? You can start with the first sentence. When concentration SO3 increase, the system will reduce the disturbance. This second sentence. The system will reduce the disturbance by decrease the concentration SO3. So now the third sentence, so the equilibrium position will shift to the right side. So which is a consume the concentration for the SO3. So that means that amount of reactant will decrease because they shift to the right side, and amount of product will increase. So at the end, equilibrium constant can remain unchanged because only temperature will change the K. Now we discuss the case 2. Let's say product is removed. So let's say one of product is O2. O2 removed meaning that the concentration O2 will decrease. So meaning how to reduce the disturbance, you must increase back the concentration O2. Increase concentration O2, you must produce it. Maksudnya dihasilkan, dan kepekatan O2 baru boleh meningkat. Okay, dalam soalan ini, how we increase the concentration of the O2. Okay, so that means from this equation, you must produce O2. So how you produce O2, system also will shift to the right side. So when they shift to the right side, SO2 and O2 will produce, and then concentration for the O2 will increase. So that means for this equation, they shift to the right side. Okay, student, you don't need to remember left and right because left and right depends on the equation. You just understand you should produce it or you should consume it like this. Okay, now how you do the explanation? The first sentence is a when. When disturbance, when concentration O2 decrease, the system will reduce the disturbance by increase the concentration O2. So equilibrium position will shift to the right side. So which is a produce O2. Okay, so say delete. So they'll produce the O2. So then amount of reactant will decrease because they shift to the right, and then amount of product increase because they shift to the right, you produce more product. At the end, equilibrium constant can remain unchanged because this is not changing of temperature. Okay, hopefully you enjoy the concentration.